maybe. Normally, sine and cosine, right? I told you that this is kind of our basic graph. We know that it normally completes one cycle, one full period from 0 to 2 pi. But if you change the period, that's still okay. It just changes how long it takes to do that. But also, if you add or subtract a number inside, right? Think about what that does to x minus 2 squared. That translates the graph. Well, in a trig function, that's going to slide that graph left or right, which sometimes can look really tricky. Like, how do I know where it's starting now? Because it's slid left or right. So, to kind of show you where this formula comes from, if you just solve these for x, you can see how you can find what the new full period of that would be if there's a c value. So I'm just going to solve for x. So all I'm going to do is I'm going to add c over, and I'm going to get that bx equals c. And if I divided by b there, I would get c over b. So notice that normally regular graph starts at 0, but if there's a c value, right, if c is something other than 0, then it's going to start at c over b, as opposed to starting at 0. So c is 0, equals 0. On this one, you do the same thing, except for you're adding to 2 pi. I can't add c to 2 pi, right? So that's just going to be 2 pi plus c. And then if I divide by b, I could divide everything by b, but I'm going to break it up. So notice that I get x equals 2 pi over b plus c over b. Does 2 pi over b sound familiar to you? That's how we found the period, right? So that's just meaning that the normal end of your period with a b value plus whatever the new starting point is. So this whole thing, we're talking about a horizontal shift, again, it has its own special name for it, is just the formula c over b. If you want to talk about how much has it shifted horizontally, I like to give you this to show you where it comes from, but really if you just remember this part, you don't have to know how to get there. And instead of calling it a horizontal shift, we call it a phase shift, right? So stretches and shrinks are called amplitude. How long it takes to complete one cycle is called a period. And if it shifted left or right, we call that the phase shift. And that's where we would have c over b. The good news for you is graphing by hand. We are going to look at some of these on the graphic calculator next week. But graphing by hand, I'm not going to make you graph any phase shifts by hand, but I am going to make you be able to find phase shifts, and maybe we can look at some on the graphic calculator to see how they look. Okay, so in summary, this kind of goes back to the first day. I gave you these formulas. We should be able to kind of summarize what all these letters mean now. Hopefully, amplitude and period you feel really good about. That amplitude is always just the absolute value of A. Amplitude tells me my range. The period lets me know what I do my x-axis by, right? So the amplitude lets me know my y-axis. The period is always 2 pi over b. So I know what A means, I know what B means. We can talk about the left and right endpoints of one cycle if there's a c value, right? So instead of starting at 0, we'd have to start at what b over c is. So we need to know that c over b. This is your phase shift. You can write that again. And then your book actually never mentions what d is, because there's no special word for d. D still always means the exact same thing that it has meant. If you add or subtract a number outside of a function, it's just going to translate your graph up or down. But I like to throw that in there, that d is a vertical shift or vertical translation. So if you have sine of x plus 7, where 7 was outside of the function, so we just take that whole sine graph and move it up 7 because it's not going to touch the x-axis. So this page is kind of like, in summary, what do all the transformations of sine and cosine look like? Okay? I think I have sound effects. So this is what you definitely are going to do on your homework today, and you're definitely going to have a question on your test like this. I'm not making you graph this, but I want to know that you know what all those things into my problem. So I want you to be able to tell me the amplitude, the period, the phase shift, and the vertical translation are in this problem. So on a test, that's probably like 4 or 5 point questions, right? Alright, so what's the amplitude, the number in front, absolute value, is 1/2, which means this graph would be kind of squished down, right? Like not even going up to 1. So that was right answer. You did a good job. Hooray! Someone needs to get one wrong so we can do that. Period. Tyler, how do I find the period? And what's B in this problem? Is this whole thing B? No, we better do try again. Oops. That's funny, right? What is it? Tyler, back to you guys. Try again. It's just pi, right? This is bx minus c. So it's just pi. So what's the period on this one? It's just 2. So that one we haven't graphed. This function yet where you just go by 1, 2, 3, 4, and you would on this one because there's a pi already in the problem, so you wouldn't put another pi in the problem. That's crazy, right? All right, this is a new one. Phase shift is c over b. Come back here for just 1 second. Notice in the equation it's bx minus c, just like we've always done with horizontal translations. That minus really means like moving to the right, and if it was plus, then that really means the negative value. So when you do this, if it's minus, right, the c value is really just 1. It's not negative 1. So this one would be really not so fun to graph because the phase shift would be, who wants to give to me? 1, c would be 1, but what's b? Pi, which means this graph has shifted 1 over pi units, which would be terrible to make an x graph, an x-axis, when you're starting at 1 over pi, which is an awful axis. Right? That's why we're. But it could be, like if this was just a 2x, then that would be just shifting by 1/2, and that one wouldn't be so bad. Oh, I don't know if we should count that right. I'm sure she had that every time you did it on myself. What about the vertical translation? Is there a vertical translation? There's nothing added or subtracted outside of that function, which is how most of our functions are, which means you can say none, you can say 0, I don't care. I'm going to say 0 because g is technically 0, but if you said none, that's okay too. Oh, sorry. Wait a second. What should you do first when you're graphing? After you're done crying, what do you do next? Amplitude period. And again, I'm not going to give you any to graph by hand that have a phase shift. Sydney, what's the amplitude of this one? Which one is amplitude? It's the A in front, so what's the front of cosine on this one? That's like -1, right? But amplitude is never negative, it's the absolute value. So the absolute value of this would be 1. Which means there's really not a stretch or a shrink there, right? Like it's not going to go any more. But what does this negative mean happening to my graph? It's flipped, it's reflected, right? So everything I normally get should be flipped over. So maybe you want to write that it's reflected in x-axis, just to remind yourself. Especially if you're going to be one of those people that doesn't make it like right now. You want to get really flipped over. Period. Sammy, what's my formula for period? And what is b in this problem? B is 2 pi, so I get 2 pi over 2 pi, which means that my period is 1. Again, doesn't happen very often, but if there's a pi in the problem, that's going to happen. So again, to me, it's all about two things. One, knowing what the graph looks like. What does cosine normally look like? And two, knowing what to label your x-axis. And the period is the key to that. So 0, and I'm going to end at 1. Half of it again. So what's half of 1? And what's half of a half? And I always say, like, what's in between there, but sometimes if you don't know that, it's always adding these two together will always get you to this one. But halfway in between 1/2 and 1 is just 3/4, right? It's like 1/4, 2/4, 3/4, 4/4. Kind of just notice we've taken the pi out of it, because pi's up here. Kind of weird, but if there wasn't a pi up there, this would be pi fourths, pi halves, 3 pi fourths, and pi. We just don't need it, because the pi's already in the problem. On my test, I'm always going to ask you to give me 2 full periods, which to me makes the most sense to do one positive and one negative. So I'm always going to make my graph go by this period. So if the period is just 1, I'm going to make my graph end at 1. And I'm going to go over here and I'm going to make my graph end at -1. And I'm going to put those exact 5 key points every time. Halfway in between, and then half of that. Should be even the 6th. And again, you can label them all if you want. I just tend to feel like it gets a little squished sometimes, especially how big it is. And my y value, because my amplitude is only 1, I really only need a 1 and -1. If you want to make more, you can make more. And then this is where it's up to you. What do you need to do? Do you need to take each of those x values and plug them in and actually get the y value to go with it? It will work every time as long as you're getting the correct y value. Do you know what the graph looks like and you can just make the points? That works too. To do that, or you can just kind of know these values and fill them in. I'm going to do like we did on the last one. I'm going to do the picture first to kind of get you the visual, and then we'll talk about how the y values work. Normally, cosine starts up at 1, but because it's negative, it just means it's going to flip down here. And then it goes to negative either way, right? 0 is still 0. I'm sorry, it's negative. So normally it starts here and it goes down, and now it's going to start here and go up. And then halfway in between should always be, usually it's the lowest point, and now it's flipped up. So it's the highest point, then it goes back to 0, and then it always ends where it starts. And that's what I feel like if you feel really lost on these graphs right now, that's where you should be practicing. Do I know what the graph looks like? Do I know the 5 key points every time? And then cosine's even, so it's exactly the same on the other side. And then you just make your graph. It's flipped over. Every time you can plug these in. If I plugged in 0 up here, I would get negative cosine of 0. It's 2 pi times 0 is 0. Cosine is 1 times negative. Gives me my -1 value. And it'll work every time. The problem is, you're going to have a no calculator part of your test, which means if you're plugging these in every time, you've got to know your values correctly. When I plug pi fourths in there, 1/4 in there, 2 times 1/4 gives me my 1/2 times pi, gives me negative cosine of pi halves, which is still 0. And every time, these 5 points will give you those key points, where if you plug 1/2 in there, you get pi. When you plug 3/4 in there, you're going to get 3 pi halves. When you plug 1 in there, you're going to get 2 pi. So that's why those key points are so important, to know that those are your values. Cosine of pi is -1, but a negative that gives me my +1. Cosine of 3 pi halves is still 0. And then I end where I started. So again, those values, the only thing that's changing there is the negative because of the split phase. Next week, we're going to graph the other one. We're going to graph tangent, cotangent, and secant, and cosecant. So you really want to make sure that you know these because you really kind of build all the other ones off these guys. Smooth curves, no sharp points. Is it ever going to go along with -1? So notice I just questions about that? And then some on your homework are just like the ones that are on the bottom of that worksheet that you guys already did, but this is exactly like I copied this from your book on page 392, and I think you're doing either number 30 or number 32, that says they give you the equation even, right? That's better than the ones on the worksheet. And it says state the amplitude in the period. But then the extra part is they give you the equation, so they want you to tell me what's the window on this, what's my x-axis go to, and what's my y-axis go to, using what I know about the amplitude and the period. Okay? Right? So you know how normally they give you that little window at the bottom. On this one, they want you to give the window. Meredith, what's the amplitude? 3, because the amplitude is the absolute value of this. Christy, what's the period? Because 2 pi over b is 2, the period is pi. Right? You did that on yesterday, giving the amplitude and the period. I hope we're feeling really good about that. So now the new part of this is I want to know what's the x-axis go by and what's the y-axis go by. And if you just want to write out x-axis, y-axis, you can't. If you do it like the book does it, they always do like brackets, like this is the x-axis, and then they say by, or they could even put an x there. And then they put the brackets for what the y-axis is. That's always confusing. So probably the y-axis is easiest, but just be really careful, right? People want to say, well, the y-axis goes from -3 to 3, because that's what we would make our y-axis go by. But does this just go from -3 to 3? And it's a little bit taller than that, so just make sure you're really careful there. Right? That's 3, and it actually goes one more than that on both ends. Right? If it only went from -3 to 3, the very top of that graph would touch the top of that window. So we would want to say that's -4 to 4. When we graph on the graphing calculators next week, really important that you make your window fit your graph so that you can see the 2 periods there. And so you want to know, what should I make my window? The x-axis, kind of like the worksheet of how did you get your equation from the picture, is you want to kind of think how many periods are shown here of this function. So if this is cosine, it's negative cosine, kind of like what we did, right? So it starts here. Where does 1 period end? What period is cosine? The highest value and then ending back where you started, right? So this is 1 period. So how many periods are shown on the cosine section? 2 full periods, right? Because then it goes back up again and it ends back exactly where 2 periods. So if the period is pi, what does this mark right here have to be? 2 pi, right? Because this would be pi. And then if we go again, it's pi plus pi. 2 pi. And you can see that the other side is exactly the same. So then we're just going to say -2 pi. So kind of similar to the worksheet, but instead of you writing the equation, they give you the equation and you have to say the window. So again, kind of practicing how do you recognize 1 full period and then what would the x and y axis go by. Okay? So it kind of maybe seems like a lot of homework. Maybe why I gave you, oh wait, I forgot about it. Okay, so this is like, it doesn't matter to print this off because it's interactive. But just to kind of show you what A, B, and C do to the problem, right? A is the amplitude, so you can see I've already made A 4 on this one, but I can go back to 1, and you can see that when I make A bigger, it's just going to stretch it more. Unfortunately, it doesn't let me do decimals on this. It just goes negative, and a negative A does the same thing that a positive A does. Let's do that, of course, so you can see it. B, that's what we did period change, right? So you can see as I make B bigger, it actually makes my period smaller, right? Because it's 2 pi over B. So think like 2 pi over 10 or 2 pi over 20. That like eventually is going to like get the zooming line. And again, it doesn't go fractions, which I wish it did, so you could see it stretching it out. But C, I really did this for C, because watch what happens when you give it a phase shift. It's going to take this, and sine's not necessarily going to start at 0 anymore. If I shift that over, right, and I know that's not perfect there, but do you see how as I shift that over, sometimes it's just going to get back to where I started, but sometimes you can make a sine graph look like a cosine graph just by how the phase shift you did here. And the same thing with cosine. Right? That's cosine. I think that's what's up. Oh, I want that to be 0. Cosine starts normally on the x-axis, but as you put a phase shift in, then cosine could just start like that, and that's why it's a little bit harder to graph those as you do that. So I thought that was kind of interesting. Let me think through it looks like a lot. It's really a lot of writing here. 30, 33, and 34, I think those are the ones where you're looking at the graph and sitting in the window like we just did, so that's not so bad. And then 44, 47, and 48. I don't care what the directions say on those, which is why I wrote my own directions. I want you to graph 2 complete periods. So 44, 47, and 48, I want to see 2 complete periods graphed. And then the rest of them kind of talk about phase shifts. We'll probably talk about 54 and 55, but kind of matching up. Which one of these functions would match this function? Would the phase shift do the exact same thing? And then it jumps to our first example. Save the amplitude, save the period, save the phase shift. You don't have to graph any other ones besides 44, 47, and 48. Right? I think the last two are okay, so Monday we'll talk about this. Monday we might also look at, I don't know how to decide yet. We want to grab a calculator yet, or we want to look at something else before we do that. But definitely we're going to have a homework quiz beginning of the week, like Monday or Tuesday, because I got to see how we're doing on this graph and stuff. Okay?